Yeah, so a very good evening to everyone. Uh, so I just finished the session actually from 6 to 7, but I had missed out recording the session, so I'm re-recording it for those who might have missed out on attending the session from 6 to 7, and they may use this particular recording for reference later on. So in this week, we discussed some questions related to planning. Uh, Basically the graph plan and the AO star methods, and we applied these two to the same problem domain that we had discussed in the previous week. And so let's just quickly go over the problem domain once. Okay, so these are the predicates that were given to us. So at X location basically means that a person X is at a location called low. Okay, hospital appointment X basically means that a person X has an appointment in the hospital. No jab X means that X has not got any jab of the vaccine. Basically, X is unvaccinated. One jab means that a person has one jab of vaccine, and two jab means that the person has two jabs of vaccine. Okay, ticket X comma event basically means that a person X has a ticket for a particular event, which is a concert, maybe a flight or a train. Okay, in our example, it is a concert, but it could be any event. And finally, attending X comma event is uh, basically says that a person X is a part of part of the event, or basically X is attending that event. Okay, so these are the operators that are given to us. Okay, so get jab 1 basically means that person X gets the first shot of vaccine, and the prerequisites for that are that the person has no jab of vaccine before, the person has a hospital appointment, and the person is at a particular place, is at the hospital basically. The negative effects are that no jab and hospital appointment and at X hospital are basically no longer needed, and the positive effects are that the person now has one jab of vaccine. Similarly, get jab 2 means that a person has got the second is getting the second dose of vaccine. Get appointment means that the person is getting an appointment to the hospital. Go operator is for the person is going to a hospital, have given that a prerequisite that this person already has an hospital appointment, and the positive effects are that this person is now at the hospital. Book operator means that the person is booking tickets to the certain event, which is a concert in our case. We'll look at it later on. And attend basically means that a person is attending that event given these particular prerequisites and positive effects and negative effects. So this is the information that is given to us. This is the initial state. Okay, and we are given this information, basically no jab for Aisha. So we have three people, basically Aisha, Anisha, and Amol. And we are given that Amol has 2 shots of vaccine. We are given that Anisa has only 1 shot of vaccine, and we are told that Aisha has no shots of vaccine. Also, Aisha is at the hospital and Aisha has an hospital appointment. And the goal that we are to reach is that all 3 of them have to be attending this event, which is a concert. Okay, so these are 3 sub goals. And in our case, we in fact may solve these sub goals independently. So let's look at the question at hand. So we discussed the problem domain. So this is the first question. So from this set of actions, basically from A to K, what are the actions that will be present in the first layer of the planning graph being constructed by the algorithm GrpahPlan? So if you remember, the way GrpahPlan proceeds is, okay, so one initial information before that. So if you recall from the lectures, mutual exclusion. So 2 actions A and B, A belonging to a certain action set and B belonging to a certain action set are called mutex if one of the following holds. So competing needs, inconsistent effects, interference, and there's another condition. So Professor Deepak Khemani has gone into the details of each of these conditions separately. So I would encourage you to revisit the lecture and see for these 4 conditions and convince yourselves of the validity of these. Yeah, sorry for that. So we'll be needing this concept later on when we are solving the GrpahPlan algorithm. Okay, so let's move on to the solution. Yeah, so this is the solution that we just discussed. Let me move on to the full complete solution. Okay, so this P0 is basically the initial condition that we are starting with. Okay, so we were told that Aisha has no jab of vaccine, Anisa has one jab of vaccine, Amol has two jabs, Aisha is at the hospital, and Aisha has a hospital appointment. Okay, now based on all these conditions that are given to us, we are to first find what are all the actions or operators that are applicable given basically all these conditions to us. Okay. Okay, so if you recall from the last week, we discussed what are the possible actions applicable for each of these persons one by one. So if you recall, so we are given that Amol has two jabs of vaccine. And if you revisit the set of operators that we had, the only operators that are applicable, let me first erase all this so that it doesn't cause any confusion. Okay. So the two operators that are applicable in this case are get appointment and book event. Why? Because see, get appointment has no prerequisites, so this will be applicable in all situations. And book event has only one prerequisite, which is two jabs, which we know is given to us that Amol has two jabs. Okay, so these are the two operators from for Amol that we can apply: get appointment and book. None of the others, because for the other operators the preconditions are not met. So we add those to our first action layer, which is A1. Okay, so this is basically this book Amol concert is we are adding. Okay, and the prerequisite for this one is having two shots of vaccine. Okay, and we are using this yellow edge to basically denote the precondition, and we are using this blue edge to denote the positive effects, which is that Amol now has a ticket to this concert. Okay, this is the positive effect, and this operator does not have any negative effects, so we are not adding any negative edge to it. Okay, and the other operator that we were supposed to add was get appointment Amol. Okay, this does not have any prerequisites, so hence there is no prerequisite edge over here. The only positive effect is that Amol now has a hospital appointment. Okay, sorry for that. Yeah, Amol now has a hospital appointment, so we have added a positive edge for that. Okay, so and this has no negative effect again, so we don't need to worry about it. Okay, now let us look at what are the conditions for Anisa. So for Anisa, we are told that one shot of vaccine is given to Anisa. This is the information that is given to us. And based on this condition, the only operator that is applicable, let's see, sorry for that. Yeah, so the only operator that is applicable is the get appointment operator. Why? Because this does not have any preconditions, so this is applicable, and none of the other operators preconditions are met for Anisa, right? So you can verify this. So get appointment Anisa would be the operator that we are going to add, and that's exactly what we have done over here. Basically, get appointment Anisa. Again, this doesn't have any positive, this doesn't have any prerequisites, so no prerequisite yellow edge, and this has one positive effect, which is hospital appointment for Anisa. Okay, so we add this one, and again no particular no negative effect, so no negative edge as well. Now for Aisha, we are given three information: no jab Aisha, at hospital Aisha, and hospital appointment Aisha. So based on these three pieces of information, the yeah based on these pieces of information, the operators that are applicable in this case would be get jab 1, get appointment, and go. Right? Because we are told that Aisha has no shots of vaccine. Hospital, she is at the hospital. She is at the hospital and she has a hospital appointment. And get appointment has no prerequisites applicable in all cases. And Aisha has a hospital appointment, so this go operator will also be applicable, right? So we'll add these three operators: get jab 1, get appointment, and go. Okay, so yeah, so we add get appointment Aisha. Okay, this also does not have any yellow prerequisite edge, but it has a positive edge that goes to hospital appointment Aisha. Then we have go Aisha hospital, which has a prerequisite edge to hospital appointment Aisha, and it has a positive effect to at Aisha hospital as per the operator's definitions. And then we have get jab 1 Aisha, okay, which has prerequisites of having no jab at hospital and hospital appointment. So these are three prerequisite edges that we add: this one, and this one. And there's one positive effect, one jab. Now remember, in this case we have some negative effects as well, which is no jab Aisha. This is a negative effect. We mark this using this red edge. We have at Aisha hospital a negative edge. So this is a negative, and hospital appointment Aisha is also a negative edge, right? So we add these three negative edges. Now, if you remember, there was another kind of operator called a no-op operator, which is basically depicted by this, which helps us to simply copy these predicates from P0 to P1 like this, right? An example here is, so this particular no-op operator has a prerequisite no jab Aisha, and it has a simply one positive effect, no jab Aisha, basically copying this information from P0 to P1. Okay, and we do that for all of these conditions if not done already. Okay, so we add all these, and this is set of P1 that we arrive at. Now, another thing that we must look at, which of these actions from this action set that we have got are mutually exclusive, right? So if you see, let's consider this get jab 1 Aisha. So this has one positive edge. This has one negative edge to no jab Aisha, while this no op operator has a positive edge to no jab Aisha, right? So these two are mutually exclusive, which we are marking using this zigzag red path or red edge. Okay. Similarly, get jab 1 Aisha and go Aisha hospital are also mutually exclusive because go Aisha hospital has a positive effect at Aisha hospital, and get jab 1 has a negative effect, right? So these two are also mutually exclusive. Similarly, you can verify the others for yourself. So we basically have 1, 2, 3, 4, and 5 mutex relations over here. Okay, so this is a part of the planning graph that we have just constructed. Okay. Okay, so now I'm going to share. Yeah. So what we saw just now was part of the planning graph, and for all the three persons together. Now, as I said earlier, we could have solved them separately, independently as well, and this is basically the planning graph for each of these persons separately. So this is the planning graph for Amol, and if you look over here, basically, we started with 2 jabs for Amol. Okay, this was the only condition information given to us about Amol, and the 2 actions applicable in this case were book Amol consult and get an appointment for Amol, and these had certain prerequisites and positive effects and no negative effects, right? So this is the case, and we drew our planning graph for Amol till P1. Okay, so you can later cross check and see whether we did it correctly, and you can take your time to convince yourself. Now this is the planning graph for Anisa. Okay, So P0, we started with one information about Anisha, which is one Anisha had only one jab. Okay, and the only operator that was applicable in this case was get appointment Anisha, right? So we add this operator in the first action layer, and it has its particular prerequisites and positive effects, no negative effect again. Now if we look at this, is the planning graph for Aisha. This is the most complicated one, or the most lengthy one. So we were given three pieces of information about Aisha, and we incorporate all of them, and we see that there are three possible actions that could be applied in the first action layer. Right? Get appointment Aisha, get jab 1 Aisha, and go Aisha hospital. And we add the respective prerequisites and the positive effects marked by these black edges. And the negative effects, remember, here are marked using this bold red edges, right? And these dotted red edges basically indicate when two operators are mutex, basically. So as we, if you recall, when we, like we just saw over here, get jab 1 Aisha and go Aisha hospital were mutually exclusive, right? A similar thing is depicted over here. Get jab 1 Aisha and go Aisha hospital are mutually exclusive. Similarly, this is also mutually exclusive with some no op operators basically, and you can see, so there are 1, 2, 3, 4, 5 mutex uh, edges over here, and also in our graph we had 5 mutex edges, right? 1, 2, 3, 4, and 5. Okay, so while I'm not going into the details of all of these steps, right, I encourage you to solve or form the planning graph for all these three people, either independently or together, or whichever way you're comfortable with, uh, on your own. And I'll be sharing this whole planning graph with you guys. I also showed it during the live session, which I just took, and I'll be sharing it with you guys. And when you finally draw this whole planning graph by yourself on hand with your hands, you can verify it for yourself whether you drew the correct planning graph or not. Okay, so once we have the whole planning graph, so recall I just showed you the planning graph till P1 basically, okay, P0, A1, P1, and you can fill in the rest later on when you have time. Now, suppose once we have formed the whole planning graph, okay, so in this example, we reach till P7, okay, so we see that attending Aisha concert was one of the sub goals. Yeah, right. So this is one of the sub goals, and now we will look at what is the possible action that could have been applied for us to reach this particular predicate, attending Aisha concert, and that is attend Aisha concert. This particular action, and this has again a particular prerequisite, which is ticket Aisha concert, which becomes a we will now which we will now look at. And in order to arrive at this ticket Aisha concert, we must have taken the book Aisha concert action. Okay, so this way we will keep on moving backwards while ensuring that we don't choose actions that are contradictory to each other. Okay, and we will do that until we arrive at the P0, and that would give us our whole plan. Okay, so once you find a plan using your GrpahPlan approach that we just discussed, you can cross-check it with the optimal plan that we discussed for the exact same problem in the previous week's live session. Okay, so if you remember, in the previous week also we discussed the optimal plans. Let me just show it to you for ready reference. Yeah, yes. So these were the optimal plans for Amol, Anisa, and Aisha. Okay, so once you find your optimal plan or find your plan using GrpahPlan, you can verify using this answer whether you have actually found the optimal plan or not. Okay, fine. Now, Where were we? So our question had basically asked us, so out of these options, which are the ones that uh, will be a part of or will be present in the first layer of the planning graph being constructed by the algorithm GrpahPlan. And we have formed this particular first action layer, right? So we can check which of these are applicable, and we will see that get job 1, get appointment Aisha, get job 1 Aisha, get appointment Aisha, go Aisha hospital, get appointment Amol, book Amol concert, and get appointment Anisa will be present, and the rest of them will be not. You can verify this for yourself. Okay. Now the next question asked, what is the number of actions not counting the no op actions member in the plan produced by GrpahPlan? So again, if you recall, so once you solve the whole problem using GrpahPlan, you will see that we are in fact arriving at an optimal plan, and the number of actions for each of these three agents, if you recall from the previous week's questions, was the length of the optimal plan for Aisha was 6, the length of the optimal plan for Anisa was 5, and the length of the optimal plan for Amol was 2. So if you add all of these together in the overall plan, the total number of actions for all of them combined would be 2 plus 5 plus 6, which is 30, right? Which is the correct answer in this case. And the next question is, what is the make span of the plan produced by GrpahPlan? So make span basically means that the length of the whole overall plan that you are using. So remember, our goal had 3 sub goals, right? Attending Aisha concert, attending Amol concert, and attending Anisa concert. And although we are basically finding the optimal plan for Amol in basically 2 steps itself. However, the maximum length is for Aisha, which is 6 steps, right? So the overall plan for moving from our initial state to the goal state, which we had shown over here, basically, yeah, from here to here, we would be requiring an overall of 6 steps. So our make span would be 6. Okay, so that wraps it up for our graph plan. And next we are going to look at the AO star method, for which we are going to use this and or graph basically. So and or graph, just to give a brief recall of whatever professor had discussed in the lectures. So this is a goal tree, and we are trying to move from one goal to another sub goal. Okay, and potentially simpler problems as is written over here. So the figure is an and or graph that depicts how a problem S can be decomposed and transformed into one or more simpler problems. Okay, and each node has a particular name that you can see S, A, B, C, D, so on and so forth, and the number inside is the heuristic estimate of the cost of solving that node. Okay, and the nodes in this double circles basically are the ones that have already been solved, and the other ones have not been solved, okay, which has only a single circle. And our job is to apply AO star to see to try to find the optimal solution. Okay, so let us assume that the cost of each edge is 1 unit, and let us try to solve it. The question asks us, starting with S node, we have to list the nodes in the order in which they were expanded by the AO star algorithm. Okay, so let's have a look at what happens over there. So as I discussed over here, we basically, let me just redo it. Yeah, so we start with S, which has 37. Okay, now each of these edges has cost 1. Okay, so now we will look at which direction should we go in to so that this cost is the least among the options that we have. So one of the options that we have is this A path. Okay, so if we go via this A path, we will have the cost of 31 plus 1, which is basically 32. 31 plus 1, 32. So let's note that down. Gives us 32. Now, if we had gone via this D direction, we would have gotten 37 plus 1, 38, which is greater than this 37 or which is already given to us, right? So that is not a correct option to go. Okay. What is the other option do we have? That is to choose this BC. Now remember, this is a AND one, not OR, right? So in order to so this is, since this is an AND option, we have to solve both these. We have to include both B and C in our estimate, right? So this would give us a cost of 25 plus 1, which is 26. So 25 plus 1 plus 20 plus 1, which will give us 47, which is again greater than 37. So going via this BC direction is not going to be helpful. So what will we do? We will go via this A direction, right? And we will change this value from 37 to 32. Okay, now we are going to expand the A node. What are our options? One is E, one is F. Now if we go via F, we will get 38 plus 1, which is 39, which is greater than 31. So we will not go via F direction. We will go via E direction, which gives us 30 plus 1, which is 31. Right? So we have to update, but this, as we see, where this remains 31, 30 plus 1, 31. And this also remains 31 plus 1, which is 32. Okay. Okay. Now, and mind you, there's no better option that we have at this moment. So any other path we choose will get a cost that is higher than what we already have over here, 32. So now we are expanding E and we will choose this M direction, right? Because it has a lower cost, right? So 25 plus 1, 26. Right? So this will change to 26. This will change to 26 plus 1, 27. And this will change to 27 plus 1, 28. And we have arrived at a solved node. So we have reached a solution and we are getting a final value of 28. But is it an optimal solution though? No, right? Because initially when we were discussing options to go via A, B, C or D, D didn't seem like a good option to go from, right? But if we see later on when we go via this basically, right? So when we solve in this direction, what will we do? We have over here 12. This is the lower one, right? So 12 plus 1, 13. Okay, and this would be 13 plus 10, 23 plus 2, 25. Right? This is what we could have got if we had gone in this direction, but we didn't, right? And so we ended up with a solution that is not optimal. And the reason why that happened, if you recall, so when we began, S had a cost of 37, right? And let's say when we chose to go via A, this edge cost is 1 and we got 31 plus 1, 32, which is lesser than what our heuristic function had estimated, which is 37. This means that our heuristic function was overestimating the cost. And we know that AO star is not admissible when we are overestimating the cost, right? Hence, we didn't find the optimal solution. So let's go back to our question and see what it had asked. So our question asked, list the nodes in the order in which they were expanded by the AO star algorithm given the edge cost was 1 unit. So we first went to S, then we went to A, then we went to E. So this would be SAE. The next question asked for what is the value of the start node S after every expansion. So we saw that that was 32. Yeah. So when we expanded S, the cost became 32 from 37, right? Initially it was 37, then it became 32. Then when we expanded A, it remained 32, right? This one, 30 plus 1, 31, 31 plus 1, 32. Then when we expanded E, this became 28. 25 plus 1, 26, plus 1, 27, plus 1, 28. So our answer would be 32, 32 and 28, right? And another related question is the solution found by the algorithm optimal solution? No, it's not optimal. Why? We just saw because our heuristic function is overestimating, right? Now, in the next question, it is given to us. Now, let us assume that the cost of each edge is not 1 but 10 units, and we are to do the same thing that we did for the edge cost of 1. And now let's see how our answers change. Okay, so again we start with S, okay, which has 37. Now this we have options of going via A, via D or via BC, and the most promising one is to go via A because that gives us 31 plus 10, which is 41, while the others give 25 plus 20, 45 plus 10, 55 plus 10, 65, which is much higher than 37, so we will not go via the BC path. Similarly, D gives us 47, 37 plus 10, 47, which is again higher, so we will not go there. We will go via this A direction, okay? So we will go via A. Let me just remove this and draw it once again for you guys. Okay, so we had S, which had a cost of 37. We chose to go via A, which had a cost of 31. Edge cost was 10, so this became 37, not 37 plus 31 plus 10, 41. Okay, now what are the options that are given to us right now? We could go via this direction, right? In which case you would have 30 plus 10, which is 40, 40 plus 10, 50, right? So if we had done this edge cost is 10, this would have become, okay, let me just keep this and write it over here, and this would have become 40 plus 10, 50. But do we have a better option over here? We do, right? Choosing the D direction, not this, but D direction, because this gives us 37 plus 10, 47, which is much lesser than 50. So we will go over in this direction now. This is D, okay, and the edge cost is 10, and this now becomes 47. Now if we continue to go via D, we will see that the final edge cost would not be better, it would be larger, right? You can verify this for yourselves. So we will again shift back to this direction again. Okay, and we will expand E and we will go to M, which gives us 25. H cost is 10, so this becomes 35, right? This becomes 45 and this becomes 55. So now we have reached a solved node and we have found a solution. And now, is this an optimal solution? As it turns out this is actually an optimal solution. And you can see and check for all other paths that we could have gone via, and you will see that all other paths return a cost that is higher than 55. Now, what is the reason why we got a optimal solution in this case? Remember, when we started out, we noticed that when we went in the direction of A, remember this was 31, this was 10. So 31 plus 10, 41, but our heuristic function was telling us 37, which is lesser than 41, which means that our heuristic function was underestimating. Right? And we know that when we underestimate, our heuristic function underestimates the cost, A star is admissible. So we were able to find the optimal solution. Right? So this is basically the different stages that you can verify for yourself. Right? And again, so the order in which the nodes were expanded would be first expanded S, then we went for A, then we went for D, then we again went back to E, right? And the corresponding costs were 41, 47, 50 and 55 in each case. And whether or not we found an optimal solution, the answer would be yes. Okay, so that was the solution. That brings us to an end of today's session. And so there was one more doubt that was raised by one of the students that I missed in the last week, so I'll quickly discuss it once more. So the doubt was about this 15 and 16 questions, okay, from week 7, I suppose. So I'll quickly go through that. So basically 15th question asked us, change the eval of exactly one horizon node to get a new min-max value of 46. Which node will you change and what will be the new eval? Okay, and we are told to choose the smallest integer value possible for the horizon node that we wish to change. So let's look at how we can approach this one. So the min-max that we were getting is 42, and let's see how we were getting it from where basically. So 42 we were getting from here, from here, from here, from here, right? So basically, also this we were getting by comparing 16, which we're getting from here and here. So if we change any of these set of nodes, right, I, j, k or l, we might get an option that is favorable to our answer. Right? So let's look at all these options one by one. Suppose we change the value of I from 16 to 46. What will happen then? This node, min node, will have a value of then 46, right? Because 46 is the min of 46 and 60. Now, this max node will have 46 because 46 and 42, 46 is the max, so it will choose 46. Now we have 46 here, 46 here, so this will become 46 and this will become 46, right? So that is one favorable option for us. So changing I to 46 gives us a favorable answer. Now let us see whether changing J to 46 would be any helpful. Okay, so when we change J to 46, what happens? this min node still gives 16 because 16 is the min of 16 and 46, right? So 46 doesn't get propagated and this remains 42, and we do not have 46 as the min-max value, right? So changing J to 46 will surely not be a favorable option for us. Now let us see changing K to 46. When we change K to 46, this becomes 46, right? Why? Because this is the min node and the minimum of 46 and 65, right? Now this becomes 46 and this becomes 46 and this becomes 46, right? So changing K would be favorable. And if we change L to 46, that won't do us any good because this will remain 42, right? So changing L is not favorable. So based on these, what are the possible favorable answers we got? Is that changing I or K to 46 will give us a min-max value of 46. And that is what is shown over here, right? I 46 and K 46. Similarly, you can approach the 16th question as well. Here we have to obtain a min-max value of 20, right? So again, you can go via this approach and see whether changing K to 20 or any of the other from this set to changing to 20 will give us a min-max value of 20, and you will arrive at a particular answer. Okay, so I hope that was helpful, and yeah, that brings us to the end of this session, and I'll see you next week.